Okay, guys, uh, this is the lecture on Math 111 on function composition. So, we're working off of the textbook, chapter, I think it's 1.4. Yeah, it is. 1.4, domains of composition. Okay, so, no, not here. We go back to the beginning. Okay, so is, uh, the idea is you often one function is not enough to describe something, right? So you need to know how much. Now, we've encountered this already with cost functions. For example, we had the cost as a function of quantity, and we wanted to get the cost as a function of price. And what we did is we had a function that took prices called the demand function. It took prices and turned them into quantities. So we took we composed the cost function of quantity that gave us costs from quantities with the function that took prices and told us how much we were going to sell. And that gave us the cost as a function of how much we wanted to charge. And we use that to get the profit function then. Now, here they talk about the cost to heat a home, and that depends on the day of the year. The temperature depends on the day, and the cost depends on the temperature. Now, so the output of one function is used as the input of another. That's composition of functions. F of g of x, we sometimes use a little circle, but usually through this class we're going to use f parentheses g parentheses of x rather than the little circle. But you might see that in other classes, so that's important to know. Okay. So the idea is there's a few simple ideas based on cost functions, but I'm going to show you how they work right here. So let's take two functions that are simple linear functions. F of x is 2x minus 3. G of x is 4 minus x. Well, so I'm trying so to get g of 0, to get f of g of 0, we start by getting g of 0, because the 0 goes to the guy next to the x. So g of 0, in this case, equals 4 minus 0 equals 4. And then f of g of 0, which equals 4, equals f of 4, which equals 2 times 4 minus 3, which equals 5. So that's how we first throw the 0 into the g, and then we take the result of that and feed it into the f. Or we could do the same thing. G of 2 equals 4 minus 2, which equals 2. F of g of 2, which equals 2, is equal to f of 2, which equals 2 times 2 minus 3, which equals 1. We could take g of minus 3, which is 4 minus 3, which equals 7. F of g of minus 3, which equals 7, equals f of 7, which equals 2 times 7 minus 3 is not 11. 11. And finally, these are just some random numbers I picked. G of 5 is 4 minus 5, which is minus 1. F of G of minus 1, which equal f of G of 5, which equals minus 1, is f of minus 1, which is 2 times minus 1 minus 3, which equals minus 5. Let's bring that. Now, okay, so that's what's going on with this. Now, one of the important things about function composition is that it doesn't necessarily, it doesn't go the same way left to right and right to left. Okay, so just doing a little, if we do g of f of x, we're not going to get the same numbers. To do that, the x goes to the f. So we do here, g of f of 0 is, we start with f of 0, which equals 4 minus 0 is 4. No, that's not right. That's g of 0. F of 0 is 2 times 0 minus 3, which is negative 3. So now we're going to do g of negative 3, g of f of 0, which is equal to, let me just expand that out a little bit, equal to minus 3, which is equal to g of minus 3, which is 4 minus negative 3. You don't need that bigness. Okay, maybe I do need it to be a little bigger than that, but, which equals 7. Now, let's try g of f of 2. So this was 5, this is 7. F of 2 equals 2 times 2 minus 3 equals 1. G of f of 2, which equals 1, equals g of 1, which equals 4 minus 1, which is 3. So this guy gave me 1. This guy's giving me 3. So which order we do, G or F first, gives me very different numbers. Let's try f of minus 3 is equal to 2 times minus 3 is negative 9. And g of f of minus 3, which equals minus 9, is going to equal g of minus 9, which is 4, not r, 4 minus negative 9, which is 13. Finally, we'll try f of 5 is 2 times 5 minus 3 is 7. Right, so this was 11. This is 13. This is going to give me g of f of 5, which is going to equal 7, which is going to equal g of 7, which equals 4 minus 7, which is negative 3. So none of these numbers is the same. So these are two very different functions, g of f of x and f of g of x. And that is a very important concept. So if we go back here, you can compose functions using tables or graphs. Here we have two function tables for x, f of x and g of x. If we want to find f of g of 3, we start with figuring out g of 3, just like we did before. We find that it is 2, and then we feed the 2 into f, and we find out that it's 8. And there you see basically the same thing that I was showing you earlier. So you can solve problems with tables that way. Now, this part is what I just showed you using formulas. And we'll talk more about these kinds of problems in a minute on our next video.